We know that ice floats on water. Although ice is a solidified form of water, but still ice floats on water. Why does ice float on water? It must have something to do with Bowen force, right? So the Bowen force acting on ice must be equal to the weight of the ice so that it floats on water. Now, since Bowen force is equal to the weight of the ice, it indicates that the density of ice is less than density of water. Okay? How density of water varies with the change of state to the solidified form, okay, that is a different study altogether, and we would get back to it in the chapter on thermodynamics. But as of now, please understand that density of ice is less than water, hence ice floats on water. One of the critical examples of ice floating on water is iceberg. Icebergs are large masses of ice floating on seawater, okay. Now, what you have to do in this problem is, you have to find out, okay, let's say you have water inside a tank and a mass of ice floating on the water, okay. But you know, always a portion of ice is above the water surface, a portion is below the water surface. What you have to do is, you have to find out the percentage of volume of ice which remains above the water surface, okay. You have been given the information that density of ice at 0 degrees Celsius, okay. Let's assume that the ice is at 0 degrees Celsius. So density of ice at 0 degrees Celsius is rho ice, and the density of water at this 0 degrees Celsius is rho W, okay. Given this information that density of ice is rho ice and density of water is rho W, you have to find out what is the percentage of volume of ice which is above the surface of the water. This is the first part of the problem. This is actually a very, very interesting problem and gives you an indication of icebergs, okay. You can see that only a small portion of an iceberg or ice remains over the surface of water, and a very large portion remains under the surface. This is something which will be proved when you find out what is the percentage of volume of ice which is above the surface of water. This is the first part of the problem. The second part of the problem is a little bit more complicated, okay. Let's say you have this container. Let me show this container once more. You have this container and you have the water, okay, a small piece of ice floating, okay. Now what is done is another liquid, let's say some oil, okay, it is poured in. Now let's assume that the oil and water, they do not mix with each other. So the oil settles on top of the water, okay. So the blue colored ink is the water and the black colored ink is the oil. So the oil settles on top of the water. The information that has been given is that the density of oil is less than the density of ice, which is less than density of water. If this is the scenario, you have to find out what percentage of the volume of the ice is inside oil, what percentage is in the air, and what percentage is in water. See, it may so happen that the ice moves up and it starts floating like this, okay, with a certain percentage in air and certain percentage in oil. It may so happen that a certain percentage is in oil, a certain percentage is in water. So whatever is the scenario is, you have to first evaluate that and then find out what percentage of the volume of the ice is inside oil and what percentage of the volume of the ice is inside water or inside air. That is the second part of the problem. So try these two problems out. If you are not able to solve them out, or if you have any doubt, please get into the follow-up video for the solution to the first part and then to the next video for the solution to the second part. Thank you.